Assalamualaikum warahmatullahi wabarakatuh and greetings to all of you. Today, our group will presenting retaining structure. Okay, as you can see in this slide, this is our group members who will presenting this topic. First of all, we would like to start with introduction of retaining wall. Retaining walls are crucial for stabilizing land on hillsides or coastal areas, which preventing soil erosion and collapse. Therefore, this case study aims to defining what are retaining walls based on the literature review, exploring their advantages and disadvantages, analyzing real-world construction practices based on the case studies, analyzing two case studies of different types of retaining structures, and the last one is highlighting the differences between these type of retaining walls.
Hi and Assalamualaikum. So the next slide, I am Wan Akmadania bin Wan Jamaluddin and my friend Adib will presenting about the literature review of retaining wall. So this is the type of retaining wall that commonly used in Malaysia construction. So the first one is soil nailing. Soil nailing is technique used to reinforce and stabilize existing slopes and excavation. It involves driving holes the slope, inserting steel bar, which is the nails, that then grouted in place. So the creation basically at stabilizing slopes, retaining walls for deep excavation, and tunnel portals. So the second one is gravity wall. It relies on its mass to resist the pressure from the soil behind it, typically made from concrete, stone, or other heavy materials. Basically, we can find this retaining wall at garden walls, landscaping, and supporting small to medium height of slopes. The third one is sheet pile wall. Basically, made from steel, vinyl, or composite materials. These walls are driven into the ground to form a continuous barrier. Its application at waterfront structure, cover dam, and retaining walls for deep excavations. The fourth and the last one is reinforced earth retaining wall. It uses a layer of geosynthetic or metallic strips within the soil to improve its stability and bearing capacity. Normally, we can find this retaining wall at highway embankment, bridge embankment, and large retaining walls. So, this for start is type of retaining wall. Before the construction of retaining wall, we need to consider several factors, which is purpose and function. To define the primary purpose of retaining wall, because the purpose will influence the design, height, and materials. Second, we need to consider the soil condition. We need to conduct a geotechnical analysis to understand soil type, cohesion, and moisture content because different soil have varying stability and slope bearing capacities. Third is height of the wall. The height dictates the engineering design and material requirements. The fourth, load consideration. We need to calculate total loads, including soil weight, surcharge loads such as vehicles, and dynamic loads. Five, we need to consider the drainage because the proper drainage reduce hydrostatic pressure behind the wall and it can prevent the retaining wall to collapse or failure. Six, material selection. We need to choose appropriate materials such as concrete, stone, brick, timber, steel, and geosynthetic. It is because material choice affect appearance, cost, durability, and maintenance. Seven, design standard and codes. We need to ensure it complies with local building codes and standards. Uh, for example, specific regulation on wall height, materials, and construction method. And the last one, we need to consider the foundation and stability. Design a strong foundation to bear the wall load and prevent settlement. Consider the foundation depth, width, and type. So we need to enhance the stability of the retaining wall. So we need to consider these factors. Thank you.
Assalamualaikum. My name is Muhammad Adi bin Abdul Rashid. So now I would like to explain about the definition of retaining wall. A retaining wall is a structure designed to maintain different elevation of soil surface, providing lateral supports to vertical soil slope to prevent collapse. Common material for constructing retaining wall include treated lumber, poured concrete, concrete block, rock and stone. Each which verify is use of lifespan. Retaining wall are crucial in various engineering applications such as irrigation, bridge, railroad, and highway. Cantilever retaining walls suitable for height up to 6 meters use the cantileveration of the heels, toe and stem slab to resist lateral earth pressure. However, for height above 6 meters, the design becomes uneconomical due to the increased earth pressure and moment. Counterfront retaining wall, which require more steel and a larger base of an offer alternative. So now I would like to continue with the objective of retaining wall. Retaining wall makes slope areas functional. Essentially, the wall flattens the slope so that the water and soil don't flow downward. Retaining wall can also help provide pedestrian access to a slope area. Instead of walking up and down the slope, a retaining wall can make it easier to walk since the area are flat. The retaining wall can also be used to direct the flow of water in certain areas. This is especially helpful when a slope is near a body of water. Keep in mind that there are many state and city regulations when it's come to a building wall for this purpose, so it is important for you to do a research before finding a new building. Next was to prevent the erosion. As previously stated, one of the main purpose of this type of wall is to hold back soil. If the soil slope downwards, it could easily create erosion in the area. A retaining wall can also be used to hold back water without a wall for this purpose. The seroline can be exposed to the erosion, causing the sea lines to shift. When building a wall to prevent erosion, it is important to keep a permit law in mind. Thank you. So now I would like to continue with the advantages of retaining wall. Retaining structure are used to retain soil or other loose material in area where there is sudden change in ground elevation. In addition to providing necessary support to the soil, retaining wall are also help to reduce the surface runoff by reducing sharper gradients. This reduces the speed at which water travel over the surface and thereby reduce erosion. Next was to prevent the sinkhole. When heavy rainfall infloods the ground, it can adore the bedrock. When this happens, sinkhole can form. Areas with limestone bedrock are especially susceptible. According to the US Geological Survey, the most sinkhole-prone state. Retaining wall help prevent sinkhole by redistributing water and limiting pooling. Next is to add the structure support. Your home needs a solid foundation, and that includes a foundation with sturdy soil. If your lot sits on the incline, a retaining wall can protect the integrity of your foundation and provide the structure support necessary to keep your home safe from unstable soil. Furthermore, the function of the retaining wall is to pleasing the aesthetic value. Constructed of concrete, natural stone, brick and treated wood, retaining walls are an elegant, aesthetically pleasing upgrade to your home curb appeal. Retaining walls allow you to redesign and slightly drop off, create a beautiful flower beds and add a texture to your property. And now I would like to continue with the disadvantage of retaining wall. One of the most crucial kind of retaining structure is a retaining wall. In a wide range of applications including irrigation, railway, bridge and highway engineering, it is heavily utilized. The purpose of this study is to establish a relationship between a different retaining wall parameter and demonstrate their comparative investigation based on Majahan B 2019. Certain retaining wall experience vertical fissures in the pore concrete as a result of extreme pressure or temperature fluctuation. Certain type of retaining wall, like a brick wall, are not able to endure high soil pressure, which can lead to foundation failure or brick breakage. Whenever you use a wood for a retaining wall, your property may become the target of termites. The gravity retaining walls weight is the only things that can resist lateral earth pressure because they need a high gravity loads offset the horizontal soil pressure. Gravity retaining wall are frequently very large. Bearing, sliding and overturning force must all be taken into account when constructing a gravity retaining wall. It can be constructed from a variety of materials such as masonry units, concrete and stone. The main purpose of retaining wall are to stop soil erosion, make steps terrains into usable beds and provide functional or environmental landscaping element. They may be independent building or a component of a bigger construction project like a building. If the wall is higher than 1 meter close to a road or walkway or higher than 2 meters elsewhere, planning permission is needed. Independent freestanding retaining wall might not need to comply with the building regulations, but all structure needs to be structurally sound and well maintained.
Assalamualaikum. My name is Muhammad Abil Ashraf bin Muhammad Afif. I will be presenting a case study on the reinforced concrete L-shaped retaining wall project. For project overview, the client for this project was Lembaga Perumahan dan Hartanah Perak (LPHP) with Seri Bumi Makmur Sendirian Berhad as the contractor. The project was located in Mukim Bota, daerah Perak Tengah, Perak Darul Rizwan with a total construction cost of approximate 500,000 ringgit Malaysia. The structure type was a reinforced concrete L-shaped retaining wall and the construction period is within 80 days. In designing the retaining wall, the contractor applied two main theories which are column theory, which accounts for the friction between the wall and the soil, and Rankine theory, which simplifies the prediction of lateral earth pressure by assuming a vertical wall face and ignoring wall soil friction. One of the key design considerations is limiting the wall height to a maximum of 5 meters. For stability, the contractor positioned the footings near the ends rather than in the middle and ensured the toe was at least 0.3 meters thick. Proper stem positioning at the footing edge was also crucial. Continuous monitoring and maintenance of soil carrying pressure were essential to prevent any damage. Expansion joints were placed between the slab and wall to prevent cracking, and well-compacted soil behind the stem to support the wall's stability. As you can see here, this is the slide that shows the detailed drawing L-shaped retaining wall structure that has been proposed by the contractor. The construction began on 12 November 2019 and was completed on 12 March 2020, taking a total of 80 days. Key stages of the construction process included site preparation, excavation, footing and stem construction, whip holes installation, backfilling, final compaction, and inspection. For site preparation, it is involved clearing the site and marking the wall location. Excavation included digging and preparing the trench for the footing. Footing construction involved pouring and compacting concrete, while the stem construction required erecting the vertical part of the wall and maintaining the better ratio. Whip holes were installed to ensure the proper drainage, preventing sliding or overturn failure. Backfilling involved by compacting the soil behind the wall. Final compacting ensured the backfilled soil was well compacted to support the wall. And lastly, the inspection by SO ensured the wall met all design specification and safety standards. Moving on to the next slide, which is testing and monitoring. Testing and monitoring included the concrete slump test to ensure consistency and workability of the concrete, and visual inspection to check for surface flaws and structural integrity. The contractor then documented all inspection results and observation for maintenance planning. As you can see beside, these are the steps for the slump test process. Moving on to my last slide. For issue arise, so far there is no issue when constructing the wall. It is because soil stability was not planned at the first place, which may risking the project's structural integrity, which the soil might be collapsed. So the contractor addressed this by conducting detailed soil analysis and submitting a variation order to the client. This involves site assessment, preparing the variation order, obtaining client approval, and constructing the retaining wall. That's all for the case study one. I'm passing this to the next presenter. Thank you.
Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azra Ahmed Rosli, and I'm going to continue our group presentation by explaining the second case study. So, this project are about perbaikan cerun menggunakan kaedah rubber wall. It is a collaboration work between Kementerian Kerja Raya Malaysia and also Pintas Utama Sendian Berhad as the main contractor for this project. So this project are actually located in Lumut Perak Tengah, in Negeri Perak. It is budget around 500,000, and this project is scheduled for completion within 6 months from April 15 to October 14, 2024. So that is the brief introduction regarding the case study. So now let's proceed the presentation with the analysis of the design for the wall. Okay, now let's proceed with the design analysis for the rubber wall retaining wall. So basically, rubber wall is a retaining wall but made of stone, made of irregular stone with various kind of size from smaller one to the bigger one. So in this retaining wall, there are four engineering main considerations that they have implement. So number one is the foundation. So basically, they are building up a solid foundation, typically a concrete slab or well compacted base. It is very essential to prevent settling of the rubber walls. It provides a stable platform that distribute the weight of the wall evenly. So it can also reduce the risk of uneven settlement or structural failure over time. Okay, for the second one, this project implement a drainage system alongside the retaining wall. So a proper drainage system critically important as they prevent water accumulation behind the wall. Accumulated water can create hydrostatic pressure, which can destabilize the wall. Drainage solution like weep holes, perforated pipe, or French drain ensure water is directed away from the wall, maintaining its stability and longevity. So as for this project, they are actually horizontal drains. They are being built up alongside the retaining wall. It is to ensure that the water can flow in between the retaining wall, so the water pressure will not um, move the retaining wall when the pressure is too high. So number three is the reinforcement, the use of reinforcements for the retaining wall. So steel bar are often incorporated into rubber wall, particularly in taller or load-bearing structure. So this reinforcement enhance the wall structure integrity by providing additional tensile strength and resisting forces that could cause deformation or collapse under load. And the last one is the height to width ratio. So the height to width ratio determines the stability of the wall against the lateral pressure. A proper ratio ensures the wall can withstand external forces without overturning or buckling. So taller walls typically require wider bases to support their height, minimizing the risk of instability and ensuring the long-term durability. So that's all for the design analysis, and now let's proceed with the construction method for the rubber wall. So here is the method of construction. So there are five main steps of the process for the rubber wall construction. So firstly, the foundation is very crucial, where we start by preparing a solid base, typically a concrete slab or well compacted soil to ensure the stability and prevent settling over time. And the second one is the next placements of stone begin irregularly. Shaped stone sources from locally from quarries or river are carefully selected and arranged. from larger stone to the smaller one, providing a stable foundations and distributing of weight evenly. So mortar is used between the stones to bind them together, enhancing the wall strength and stability. So smaller stones, known as neck, fill gaps between larger stones, improving the structural integrity and load distributions. And we also installed a proper drainage system where we incorporated drainage systems such as sweep hole or perforated pipe behind the wall to manage water build-up. This is to ensure or prevent hydrostatic pressure, which can destabilize the structure. So throughout the construction, meticulously attention is paid to the height to width ratio. Maintaining a proper ratio ensure the wall can withstand the lateral pressure from the retained soil without overturning or collapsing. And finally, the wall is finished with a capstone or coping to provide a neat appearance and protect the top layer of the stones. So, in conclusion, for the method of constructions, about a rubber retaining wall combines sturdy construction technique with natural material to create a durable, effective solution for managing slopes and enhancing the landscape appearance. So testing and monitoring during the construction of the rubber wall. So before large scale of concrete productions, trial meets for grade 30 concrete uh, are being tested to ensure it meets the strength and durability requirement through cube mold testing after 7 days and 28 days. So tensile tests assess T12 steel rebar in double bars to confirm they can handle the tension and shear forces crucial for structural stability and load transfer. So bending tests for BRC B10 and BRC A8 steel bar evaluate their flexibility and load bearing capacities, reinforcing concrete against heavy loads and environmental pressure. So that's all for the testing and monitoring. So now I'm going to explain the issues and the solutions um, for this project. So in this project, a main challenge is the temporary closing of lane on the major roads near the construction sites. So the close of the lanes is for the storing of materials and parking machineries nearby the construction site. So the closing cause disrupt traffic flow and the inconvenience to the roads user. So the solution is the team developing a detailed traffic management plan led by the traffic management officer (TMO), ensuring safety with signage, barriers, and clear communication through official channels and social media. So I think that's all from me. Now I'm going to pass the presentation to Hakimi.
Assalamualaikum. My name is Muhammad Hakim bin Zulkifli. So today I would like to present about critical analysis between these two type of retaining wall, which is regarding similarities and difference. First similarity is regarding discharge water and soil system, which is both of this retaining wall implement same system, which is using UPVC pipe to discharge water and soil. For rubber retaining wall, they lay UPVC pipe from the backfilling of material behind the retaining wall throughout the retaining wall itself. While for the reinforced retaining wall, they made a whip hole in the retaining wall, and then they fix the UPVC pipe in the whip hole. Next similarities is implementation of geotextile, which is this both of retaining wall use geotextile in the design of retaining wall to achieve a specific purpose or function. So for the rubber wall, they use geotextile at the PVC pipe to prevent from the soil go into the pipe and make the flow blockage. While for the reinforced concrete retaining wall, They use geotextile at the weep hole, which is they put the geotextile at the inlet of the weep hole, so the soil cannot penetrate the weep hole and make the flow blockage. And the second part, they use geotextile in this reinforced concrete retaining wall is at the between original soil and backfilling soil, which is to increase the bonding between original soil and backfilling soil. The last similarities is method of construction, which is excavation, backfilling, and compaction. So both of these project retaining wall, they use same method of construction, involved in excavation, backfilling, and compaction. For the project rubber wall, they excavate to provide walking space to lay UPVC pipe through the compacted filling. Next, the excavation void will be filled and compacted to ensure the pipe is maintained in its position under the soil filling. While for reinforced concrete retaining wall, they excavate to provide working space to use as a space to erect a formwork and to install the geotextile at the inlet of the weep hole. While for the compaction filling, is to stabilize the soil and maintain the structural integrity for the retaining wall. In this slide, I would like to talk about the difference. First is construction method, which is rubber retaining wall. They are constructed by placing larger rock or boulder in a specific pattern and use rubber material to bond between the rock, and also they construct drainage system. While for reinforced concrete sheet retaining wall, they are constructed by pouring concrete into a mold or formwork and added steel reinforcement and also construct system drainage system. Next is material use. For rubber retaining wall, they use larger rock or boulder and also use rubber material. Uh, for reinforced concrete retaining wall, they use reinforced concrete with steel reinforcement. Next is structural integrity. For rubber retaining wall, they rely on the weight and interlocking of the rock itself and added with double bar. While for reinforced concrete retaining wall, they gain their integrity from base foundation, concrete, and steel reinforcement. Next is site location. For rubber retaining wall, they are constructed beside the main road, so they require extra precaution and traffic management. While for
Assalamualaikum, my name is Muhammad Hakim Yadi Biswamiyadi. I will presenting a critical analysis for effectiveness and efficiency. Now we start with effectiveness. Acidic sheet retaining wall and rubber retaining wall each have unique advantages that make them suitable for different project requirements. In terms of stability, RCL shaped walls are highly effective for medium to tall walls, up to 7 meters or more, offering high resistance to lateral pressure, while rubber walls are effective for low to medium height, up to 3 meters, relying on their mass or stability. Regarding material strength, RCL-shaped walls use reinforced concrete on providing height strength, durability and stability for heavy load and seismic activity, whereas rubber walls are made from natural stone which are highly resistant to water in erosion and naturally permeable. Design flexibility vary between the two. RCL shape can incorporate the drainage system and adapt to various conditions, while rubber walls, though limited in design flexibility, blend well with nature landscape, making them ideal for rural and landscape settings. Applications for RCL-shaped walls include residential, commercial infrastructure projects, while rubber walls are best suited for natural-looking areas, landscaping, and regions with abundant stock. Now I will continue with efficiency. In terms of efficiency, RCL-shaped walls are more material efficient due to the leverage effect. Although they require precise construction procedures, Rubber wool is locally sourced stone, reducing material costs and transportation expenses, but their construction is labor-intensive due to the need for careful placement of irregular stone shape. Maintenance-wise, RCL-shaped wall generally require low maintenance if properly constructed, while rubber wall may need more frequent maintenance, especially in harsh climate or seismic areas. Cost considerations reveal that RCL-shaped walls have higher initial costs due to the material and skilled labor, whereas rubber walls have lower material costs but higher labor costs, but with potential long-term maintenance expenses. In summary, reinforced concrete L-shaped walls are ideal for medium to tall structures due to their strength and durability, making them versatile for various applications. Rubber retaining walls are best for low to medium height, offering a natural look and excellent weather resistance when local stone is available. However, they are not suitable for tall or heavily loaded walls. Architectural walls are efficient and durable but costly to put and require precision. They have low maintenance and long-term durability. Rubber walls, when local stone is available, are cost-effective for material but labor-intensive and may need more maintenance. They are economical for small projects but not for large or demanding ones. Choosing between reinforced concrete L-shaped wall and rubber retaining wall depends on the project height, load requirement, budget, and aesthetic preference. Each type has unique benefits, making it important to consider the specific need and goal for the project.
In this slide, I would like to talk about critical analysis, which is cost analysis comparison. So first is cost of material, which is reinforced concrete wall require high quality concrete and steel bar, which is are more costly than the stone used in rubber wall. While for rubber wall, we can get the stone from local, which is leading to lower material cost if it readily available. While for labor cost, reinforced concrete construction did not require specialized skill, so it resulting in more affordable labor cost. While for rubber wall construction, it need a high skill labor, which is it will lead to the higher labor cost. For site condition, reinforced concrete wall often require more extensive site preparation, such as excavation and soil stabilization, that will increase in cost. While for rubber wall, they are generally more adaptable to irregular terrain and potentially reducing site preparation expense. Continue with cost analysis comparison. Next is complexity of design. Reinforced concrete wall require detailed engineering and design, which is can increase in cost, especially for higher wall and greater pressure requirement. While for rubber wall, they have a simple design, but the precise stone fitting and alignment can also add the construction cost. Next is foundation requirement. Reinforced concrete wall require more complex foundation, which is they need to have a shear key and heel slab, which is can be more expensive. While for rubber wall, they are typically have a simple design foundation, which is it can reduce cost. Lastly is safety precaution. Reinforced concrete wall constructed in a housing development site and have a lower cost due to the lack of interference with public traffic. While for rubber wall, they are located at the main road, so they need extra precaution like traffic control, barrier, and signage, which is can increase in cost.
In conclusion, retaining walls are very important for stabilizing soil that has weak load-bearing capacity. We believe that we have demonstrated the definition and purpose of retaining wall, the complexity of constructing retaining wall, how real world in construction deals with issue in a project, and analysis the differences between L-shaped retaining wall and rubble wall. We hope that our presentation has enhanced your understanding of retaining walls. That's all from us. Thank you for your time.